Hello, everyone. Thank you so much for joining us today and hope you had a great set of build sessions so far. My name is Rukmani Gopalan, and we have James Baker and Michael Rees today who will talk about running cost-effective big data workloads with Azure Synapse and Azure Data Lake Storage. Throughout the session, if you have any questions, please use the chat tool to enter them. I'll be monitoring the chat along with a few other members of our team, and we'll be answering your chat questions, doing our best. And at the end of the talk, we'll also be promoting some of the questions from the chat into the Q&A session. So having said that, enjoy the session. And James, over to you now.
Thanks, Rukmani, and welcome everyone to hopefully what you find is a informative and exciting session. Today, I want to sort of take you on a journey about how we modernize those BI pipelines that you're running to get more value at a more cost-effective level today. We then want to sort of talk about something we're really excited about, and that's .NET for Apache Spark. And then we're going to sort of see a demo, which Michael's going to take us through, showing us .NET for Apache Spark in action, as well as some shared metadata experiences that we have within Azure Synapse. So let's get going. And hopefully many of you see this architecture slide and recognize it as a BI pipeline. You'll see on the left-hand side those operational databases, which are the typical sources of these pipelines. These are typically your OLTP relational databases. The data is already pretty structured, and that's moving through a series of ETL processes into a centralized data warehouse and then out into various consumption layers. And so when we look at the architectural aspects of this, one of the things we'll see on the left-hand side, the sort of range of data sources that we can put into this pipeline are generally fairly limited. Generally we're using the OLTP databases, as I talked about, and then sort of moving that through. But it really relies on pretty well structured data to come in the first place. And then you'll also see there's a lot of data movement going on here, a lot of copying of data from database to database to database. And a lot of that copying leads to an opportunity for error. And, we've all seen BI pipelines fail as a consequence of copy failures or ETL failures, which lead to inconsistent results. And thirdly, and probably more pertinently to the talk today, when we think about the cost of provisioning all of the hardware in this pipeline, I've got a provision for both maximum utilization as well as maximum growth. In maximum utilization, I need to sort of think about dealing with all of the spikes in the load, which is quite common in BI pipelines. An example of that will be, for reporting, the first Monday of every month, everyone wants their reports straight away. And so the reporting server gets hammered on that first Monday. But then the rest of the month, it's pretty quiet. And because I have to provision the hardware in that reporting server to deal with that peak load, I don't gain any benefit of when that load goes away. Similarly for the growth, on day one, I have to forecast what the maximum growth is going to be over that hardware life cycle, which would be probably 5 years or even more. And so if I don't forecast that accurately, I'm renewing or repurchasing hardware, rebuying an enterprise data warehouse is an expensive operation. And so that just loads up the cost factor even further. So let's look at what a more contemporary architecture can do. Still has the same objectives about getting the insights and being that BI pipeline, but addressing some of those architectural and cost concerns. And so this is what we're talking about with the modern data warehouse pattern. We'll say that many of our customers are already succeeding with this pattern, really getting great value at a very cost-effective level. And so when we look at this pattern, one of the things we'll first notice is on the left-hand side, there's much more diversity in the data sources we get there. And there's also greater volume of those sources. Customers are realizing that the more data they have in these pipelines, the better the insights they get. But often that more data comes from a much different range of sources, sometimes often outside of the company. And so we don't get to control the format or even the structure that that data's in. And so to deal with that, we can't load that into a structured enterprise data warehouse straight away. And so what we do is load that into a ubiquitous data store that doesn't enforce any structure, marry that with a set of tools that can deal with that structured, semi-structured, and even unstructured data that enrich and conform that data, really gain really great insights, and then move that into a consumption layer where it can be used through visualization tools such as Power BI. And then, as I said before, architecturally, it's dealing with that greater diversity and greater volume of data. But also, you'll notice because of that ubiquitous storage layer, there's no more data movement. All of that transformation is occurring in place. And so that leads to a much greater architectural robustness. And then from a cost perspective, you'll see that everything in this architecture is a pay for consumption model. The storage layer, you pay for the amount of data you're storing today, not for what you may store in 5 years' time. And similarly with the compute layer, you're paying for the compute that you use today. And so, when I burst up on that first Monday of every month, I can elastically stretch that serving layer, and then I can quiesce it down or even shut it off completely, leading to very significant cost savings in running this pipeline. And as I said before, we've had many, many customers be very successful with this pattern. We want to continue that success going forward. We're very committed to it. And so we want to preserve all of those architectural benefits and really make this a turnkey solution. And what we've done is release that in the form of a service, and that service is Azure Synapse Analytics. Azure Synapse Analytics really is the manifestation of the modern data warehouse pattern within a single service and really leads to a great amount of value as a turnkey solution. So let's drill into a little bit of what's in Azure Synapse Analytics. And you'll see there immediately that we've got these multiple analytics runtimes like we saw in the previous architectural diagram. We've got Apache Spark. We've also got SQL, which comes in multiple forms, both as a provisioned format as well as an on-demand format. All of those runtimes are unified under Synapse Studio, giving a great user experience. And then it's underpinned by a shared metadata experience that means that I can declare tables in Spark and have those visible in my T-SQL environment and vice versa, meaning that I get out of the business of having to redeclare data structures over the same set of data and just dealing with different environments. And then all of that great goodness in Synapse is backed by ubiquitous storage layer, Azure Data Lake Storage, which really is that cost-effective and super robust storage solution to give you all of that architectural strength. And so while we're looking at Azure Data Lake Storage, let's look at some of the cost optimization capabilities of that. Hopefully by now, lots of you are aware that ADLS is built on top of the very mature and very cheap Azure Blob service. That is an object storage service that we've enhanced to add analytics-specific capabilities in there, leading to great performance and a really sort of tight integration with all of these analytics services. But from a cost perspective, the things we look at are the disaggregated model between compute and storage, meaning that I can scale compute and storage independently, meaning I'm not paying for sort of the maximum of everything, which I have to do in a co-located environment. I can pay for exactly the amount of compute I'm using and exactly the amount of storage that I'm using. That's sort of already a very significant cost saving. But then when we look at the lifecycle management and the tiering capabilities within ADLS, that makes a cheap storage layer even more cost effective. Because now as data becomes older and possibly less valuable, instead of being forced into a binary choice of saying retain the data or delete it, I can now tier that off into a very cheap form of storage and do that through a policy-based mechanism. And then the last point we've got there, which sometimes is not always obvious, that why the performance of the storage layer relates to cost optimization. But when you think about it, you're thinking back to that MDW pattern that we saw before, all of that compute layer you pay for by time. And so if the storage service is serving the data faster and completing its operations quicker, you need less time for that compute resource, therefore leading a significant change, a surprisingly significant cost reduction. So great. Let's switch gears a little bit now and say, okay, we've gone on that journey of modernizing those pipelines. We're now in Azure Synapse Analytics and having a great time with that, and certainly very cost effective. But what else do I get in that environment? One of the things we're really excited about is .NET for Apache Spark. Now, I want to stress, this isn't a proprietary version of Spark. It really is Apache Spark with all of the common features that we're used to, data frames, structured streaming. It's even got Delta Lake in there. But in the same way that Spark already supports multiple languages, it's got Scala, Python, Spark SQL, we've gone and added C# and F# into that mix. And what that means is that all of those skills that I've got in my dev teams are using .NET, building app dev experiences, they can now apply those same skills to data-centric operations. And a lot of the great features that are in those languages, such as LINQ, which is a really great functional transformation capability, which is perfect for data, I can now go and apply to my data operations as well. So let's see .NET for Spark in action, as well as that shared metadata experience that I spoke about before, as Michael takes us through a demo. Over to you, Mike.
Thank you, James. Hello, everyone. Thanks for joining us. So I will be showing you now, using an example here, the .NET support for Spark and the shared metadata experience. And let me quickly walk you through the outline of the demo and what we are trying to achieve. So we start out with a bunch of CSV files that contain tweets from people like myself that tweeted over the last couple of years. And we will be using the .NET support in Azure to do some data preparation, where we take those CSV files and transform them into two tables. One table that contains who is mentioning whom, and the other table is containing, for each tweet account, so to speak, what topics that person was tweeting about. And then once we have those tables, we will continue to use .NET for Spark in an interactive notebook experience to do some analysis on it. In particular, I would like to kind of understand what I have been doing in the last 11 plus years since I started tweeting, and see if I can figure that out just based on the tweets that I have been making. Furthermore, we will also show you how you can actually seamlessly now access these Spark created tables from T-SQL and use the SQL on-demand capabilities that Synapse offers you to directly query the data. In this case, we are looking at the mentions table and see who was interacting with me during that time. So now let's switch over and actually take a look at this. So here I have my Synapse Workspace experience in my browser. In particular, I'm having here an interactive notebook in Synapse that uses Spark. If you're looking closely here, you will notice that I attach this to a Spark data prep Spark pool that I designed and configured in a way that it's optimized for my data preparation job. So potentially large scale out and not necessarily as much memory usage because I don't expect to run a lot of like complex analytics on it. Furthermore, I'm using here the .NET Spark experience. If you are looking at the languages, obviously I can also create a Python, Scala, or Spark SQL notebook. And I can use other languages like F# and Java, also in a batch mode submission as well that I'm not going to show today. So what is now the value of this interactive notebook? If I'm using the .NET for Spark experience, I'm actually getting an interactive .NET experience. So we're using the newly released interactive .NET experience here in the notebook. And so I can just write standard C# expression such as this string tokenization here. And I execute it within seconds or milliseconds, I will get an interactive response here, which is pretty cool just for .NET experiences as well. But I would like to do Spark here. So in order to be able to do my extraction of my mentions and topics, I'm writing here this C# function that takes a tweet and depending on the prefix will extract the words that are associated with the prefix. Obviously, that's because if I have a mention, I put an @ sign in front of a tweet, and if I have a topic, I put the hash sign in front. So this now is taking the string, does a tokenization of the string, and then using some link expressions is extracting the actual topic or mention. So this is preparation. Now let's look at the actual .NET code to do Spark. So in this first cell here, I'm creating a data frame called tweets that is using the standard Spark expressions to do the schematization of my CSV files here. Please note that this looks very similar to the PySpark or Scala experience that you would have. The main difference here is that I'm using the .NET naming conventions, so in capitalization, for example, and some other .NET specific syntax, of course. But if you want to have a solution, for example, and you don't quite know how to write it, it's very easy to do a Bing search online and find a Scala solution, for example, and then just rewrite it into .NET. So now I have this data frame, but I would like to apply that extraction. So in order to be able to do that, I have to go and register my extract mentions and extract topic functions. So this is done with this UDF registration here, which takes the lambda expression that now uses this function that I defined earlier and basically parameterizes it with the correct prefix to give me the extract mentions and extract topics. So once I've done that, I can now use my previous data frame, create a new data frame here in which I go and basically project out the date, time, and author columns, and then I extract the mentions and topics out of the actual tweet string itself. This results in this table here that you see that basically contains these mentions and topics as arrays. So as a next step now, I need to separate the mentions and topics and pivot them into one row per item, which I do with my next expression here. And then I go and create my tables. Now these tables are being created using the standard Spark SQL statements that you see here, and then the save as table function, which will be creating the tables backed by Parquet inside my Metastore inside Synapse. Now you notice also that I do a repartition 1 here because there are only about 25,000 rows, so it's not a really big table. So I didn't really want to like have 200 partitions on the table and then wait a long time when I query it. So I basically put it all into one distribution partition. So now that I have created the table, I now can use, for example, another notebook here that does my actual analytics. Remember that I wanted to learn about what I was working on in the last 11 years based on my tweets. So what I do is I basically now write a Spark query that finds the top 5 quarterly tweet topics, and then I want to do some nice visualization in it. So in order to be able to do that, I'm now associating this again with .NET for Spark against a Spark cluster that is designed more for Spark analytics. So it probably has less nodes because there's less data, but I might give more memory because I might do some more interesting like processing inside the Spark worker nodes or head node. So I want to be able to make sure that my Spark program actually gets enough memory in this case. So in this case now, if you look at it, the data frame that I'm creating here is specified using Spark SQL, mainly because I'm more of a SQL person. You could obviously also use the cascading notion of Spark as well. And it's a quite complex query here that basically extracts dimensions, does some windowing queries, and some munching to get the date down into the quarters. And then the result that you kind of see if I just run the query is kind of boring. So I just get like the standard table result. So in order to be able to get a more interesting visualization, I'm using the capabilities that are built into the actual .NET interactive notebook experience. Primarily, I'm using the Plotly library, and I now take the data frame that I created earlier, and I collect it into an array and use some, again, this time in-memory local inside the notebook expressions to go and run now some link expressions to build up my bar chart. So all said and done, the result will look a little bit like this. So we'll notice that in the last 11 years since I started tweeting, I have like these 3 humps here where I basically worked on 3 different things. If you hover closely over it, you will notice that I've been working on SQL, I've been working on ADLA, and now I'm working on .NET and Azure Synapse. So you can kind of like, just by looking at my tweets, kind of figure out what I have been working on over the last 5 years. So now that's not all that I want to show you. So let me show you one more thing, which is that I can now go and actually query the table that I have created in Spark directly from my T-SQL experience. So in this case, I have a T-SQL script that runs against my SQL on demand using the database that I had specified before, and I'm reading the mentions table here. Now, if I run this, you will see it kind of executes fairly quickly in about 4 seconds here, sometimes a little bit faster. And you see here the nice table format. So you see the people that have been most actively tweeting at me. And now if I want to actually get a chart form, I can have this built-in chart visualization here. So here you now see a more nicer visualization using a chart form directly in it. So now let me go back to my slide and kind of summarize. So what I have shown you now is basically how we can use your .NET experience, make it very easy to basically take your .NET experience, bring it to your big data preparation and data processing and analysis, and also use the integrated shared metadata experience that Synapse has to seamlessly operate on your data with Spark and T-SQL at the same time. And with that, I'm handing it back to James, who will be concluding the presentation.
Thanks, Mike. It's good to know that I can still use those C# skills in my data projects. So great. Let's look at some of the resources we've got here, and you'll see down in the bottom of that slide the Azure Data Lake Storage, Azure Synapse Analytics, and .NET for Apache Spark links. And to summarize, we've thought about how we can modernize those BI pipelines to really drive cost effectiveness and architectural robustness. We've also seen .NET for Apache Spark, as well as a shared metadata experience within Azure Synapse. And with that, let's open it up for some questions.
Thank you, James. We have one question from the chat that I'll ask, and this is probably from Michael. Will .NET for Spark be supported out of the box in Databricks?
So that's a very good question. Obviously, we are not owning the Databricks product itself, but we are very much collaborating with them. Right now, you can use .NET for Spark against Databricks in their batch mode submission, and we have a couple of customers doing that. On our .NET for Spark GitHub site, we have documentation explaining how you can do that. Unfortunately, right now, Databricks is still having their kind of more proprietary notebook technology, although they are opening it up now to including Jupyter as well. And so they haven't had time yet to include that. And for them, I think the most important aspect is to get the customer feedback. So we do have a user voice entry on our own user voice for Azure Databricks. If you go and upvote that, that definitely gives our team enough additional kind of weight in going and talking to the Databricks team, but also feel free to reach out to Databricks directly if you want to see it as an out-of-the-box experience.
Thank you, Michael. That is very helpful. Interestingly, the chat was relatively silent today. I hope that there was no issues and people who did have questions got a chance to ask their questions. So what I'll utilize the rest of the time for is maybe address some of the commonly asked questions that will serve as a good starting point and guidance for the listeners to get started on their big data journey on Azure. So James, can you talk to us a little bit about how one can start thinking about moving some of their on-prem Hadoop-based workloads to Synapse on Azure?
Yeah, that's a great question. And we see a lot of customers wanting to take their on-prem Hadoop clusters, move it up into the cloud so they can gain advantage of those cost savings in the cloud. And really my sort of guidance is to think about migrating the data separately from the sort of workloads that operate on them. And the basis for that is that once you migrate the data across and basically keep your HDFS cluster and your ADLS data source in sync, then you can go and move those workloads all across at your sort of own rate without having to worry about data dependencies and sort of upstream and downstream data sets. We've got programs that go and support exactly that movement of data. We've got things like Azure Data Box to go and help migrate very large data sets. And we've also got lots of tooling to keep those data sets synchronized, as well as we've got programs within the HDInsight service to help migrate those on-prem Hadoop workloads up into Hadoop for Azure. So they're all great pointers and more than happy to share those things out.
Thank you, James. As James said, we do have programs that we are very happy to work with customers on moving their big data journey. So do talk to your Microsoft teams about these programs. We'll have probably time for one more question. Michael, this one is probably for you. The shared metadata looks interesting. Will this also work with SQL pools? Can I read a SQL table from Spark?
Yes, so the SQL pool is currently not yet enabled. It will become enabled within the summer during a refresh. So we will be able to give that sometimes this summer easily. And going the other way, we are also working on that. That will be probably closer to later this year. One thing I want to point out there is that one of the important things is that right now we are focusing on Parquet-backed tables. Please let us know in our user voice environment what other formats you want to be able to share between the different compute experiences.
Thank you, Michael. And how do they reach this user voice? Maybe you can advise the audience on that also.
Yes, maybe the easiest is since it's a link, aka.ms. I'm not quite sure. Is it Azure Synapse feedback? You might actually be able to see that in.
All right. Or they can go to feedback.azure.com and tag their responses with Synapse Analytics, and we'll find that, right?
Yes, correct.
Awesome. All right. I think that brings us to the end of this session. Thank you so much, James and Michael. And thank you, everyone, for being such a wonderful audience. Please do take a look at these resources and do reach out to us with any questions. Otherwise, hope you all had a great session and hope you have a great rest of the build as well. Thank you so much.
Thank you, guys.
Thanks very much, everyone. Bye-bye.
Great night, day, whatever.